Okay, so we'll make no excuse getting started. Obviously, we're pushing for time a bit. This is originally kind of an hour and a half's presentation, which we have kind of condensed down to an hour's presentation before. And then Rob said, can you come and cover it in half an hour? And I think it's kind of, can you do it in about 30 seconds? So we'll cover through, but there'll be, as I'm sure you appreciate, there's some bits which we won't go through in kind of full detail. But either come and chat to me afterwards, or catch me some other time, details on that. So, Mike Turpin, I work for Capita in our property and infrastructure division, running BIM for all of our offices across the UK. And the presentation in association with Rob, who helped us out on this research and development task, looking at collecting data, but using drones for kind of photogrammetry on site. So, first off, on any project, we've really got to ask the question, what is? Kind of things like what is the width of something, what's the height of something, what's the area of the site, etc., etc. Every project starts with needing to know what the project's about, where it's going to go, and how it's going to run. But what if we didn't have to collect that information? We had more information earlier, we knew stuff, we didn't have to go to site, we didn't have to make assumptions. Basically, what if we knew everything at the start of a project? That'd be a great start. So, what are the options for collecting data? So I kind of had a little think about this and thought, if you to take a project, what options do you have in front of you? Obviously, depending on size, scale, project, location, a few different options. First one we came up with was kind of Google Earth, Street View, kind of the basic things. You go onto Google, you type in your site postcode, you find it, you have a look. It's great, gives you some information. Next along, we've got kind of the next step, and we go to visual on-site photographs, inspection, have a walk around, look, see what's there, you get a bit more information. We can then go to site ourselves with kind of pen, paper, tapes, distos, whatever you want to use, kind of measure stuff up. Then we go to kind of the next stage of saying, right, now we need someone to come along, do a commission 2D survey, or we've got the option of laser scanning. So kind of, that's what we thought were the options we had in front of us for actually finding out about a project. And then we took those options and said, okay, let's try and map those on a graph and see what data we capture for each one and how long it takes. So kind of Google, Street View, mapping, whatever you use, kind of right down the bottom. So we said it doesn't really take much time to do it. It's kind of 10, 20 minutes on the internet, but also you don't really get that much information. You only get what the camera will see or what a aerial shot of the site looks like. Next up, site visits and photos. A lot more time and costs, depending on how far you've got to travel. If you're kind of working on a project halfway around the world and having flights and everything, it's not quite so easy. If it's down the road, not so bad. But you get more data. Is it that much? Is it that useful? Kind of a little bit more. Then site measurements. You go to site, you take maybe the width of the building, the length of a building, how wide a gap is, etc. You get a few measurements, a little bit more, but it takes you more time. And then kind of where we used to get to of saying, okay, let's send someone out on site for a day or two, field lights, whatever, measuring up and finding out exactly what's there and getting a 2D drawing back. And then a few years ago, along came laser scanning and kind of it started becoming used all over the place because I'd say you could argue where that comes, but it's about the same time as a traditional survey, maybe a little bit more costs to the expensive equipment, but you get a huge amount more data about your site. So that's all great, and for the last few years everyone's going laser scanning is the future, it's fantastic, it's quick, you get every measurement to the fraction of a millimetre, but you get billions of points, and sometimes we're saying actually too much data is just as bad as not having enough data. So I said, really, there's something missing in this middle bit. I said, a traditional survey is not that good if you want to put together a Revit model, because you might get a floor area and you don't know how high it is or if there's any recesses. A laser scan, for me, is usually far too much data. So this is when we looked at photogrammetry, and Rob will explain what photogrammetry is in a moment, but we reckon on this graph it comes about there. There's a lot less time, a lot less cost, but you get a huge amount more data than you would do with a traditional survey. So I'll hand over to Rob, and if I can work out how to turn his volume down. Go on, I'll let you explain the photogrammetry stuff.
I'm loud enough, don't worry. So, yeah, this is a, I don't like the term drone. This is an unmanned aerial vehicle, or a UAV. Basically, it's a Topcon Falcon, very expensive piece of kit with a very expensive camera on board. 37 megapixel camera on board, lots of gimbals on it to stabilize it. But what it's basically doing is it's taking lots and lots of photographs. And it's taking those photographs for the purposes of photogrammetry. So what it's doing is it's taking photographs at I think at 1 meter spacings with a 90% overlap, or if we're talking on angles, a 3 to 5 degree overlap. And what the purpose of that is that we take those photographs and then we put them into a piece of software like Recap or Agisoft or something like that, which then will convert by using common points that it can see between all those photographs. It will create a triangulation which will allow us to get XYZ points or XYZ points, which allow us to build up a 3D model, a 3D space from photographs, which is what photogrammetry is. It's the use of photography to ascertain measurements between objects. Am I doing this bit? Are you doing
Yeah, you can continue on.
So I'm being punished for telling Mike to squash this presentation down to 30 minutes because the presentation that we've done before has now been changed and I haven't seen it before. So you know, we ask a series of questions when it comes to setting up a photogrammetry project. You know, and we wanted to in this research find out the answers to a series of questions, really. Those questions being on the screen there, but principally, you know, is it difficult to capture? Is it, you know, what technical difficulties are we going to have? What access problems are we going to have? And by the way, there are quite a few, as we'll talk about in a minute. You know, how useful is the data that we produce? Is it accurate? Is it as comprehensive as a point cloud? So there was a series of questions that we wanted to get answered by doing this research. And we went through a staged process, really, and we ran it like any project you would run. You know, we scoped it. You know, there's an obvious question there to ask. You know, why are we doing this? I don't mean just why, in terms of why are we doing photogrammetry, but why are we? You know, if you were talking to a surveyor, you need to tell them why you are capturing that asset. What are you looking for in that survey? So we went through those sorts of questions in the scoping. Access, as I just mentioned a second ago, is a huge issue when it comes to photogrammetry service, particularly when you're using unmanned aerial vehicles, because there are a lot of laws around the subject. We'll talk about that in a second, and it should be done by a professional. You know, it's a skilled set, and it needs permissions and authorities to get access. We wanted to check what we were capturing. You know, how easy is the access on that site? And of course, you know, how easy is it to produce these? And that's something we're going to talk about a lot in this presentation. And how easy is it to produce that photogrammetry? How long does it take? That sort of thing. And eventually, what can we use it for?
So I think the key thing out of this was to work out, is photogrammetry and the use of drones one of these things that's a future, oh yeah, that would be nice, and it's kind of an idea, but we're not there yet, or can we actually do this now for real world projects? So, I'll turn it down. Just a quick video here which shows our site which we're looking at for this project. It's an old Victorian cliff lift on the Isle of Wight, right down the other end of the country. Nice sunny day here for once, and Capita were employed to replace this bridge between the top of the cliff and the top of the lift there. So obviously what we needed to know for this project to create a Revit model was how high is the cliff, how wide is it, how deep is it, how big are these panels, etc. What's the spacing for the bridge? So we had a lot of things a lot of information we needed to gather about it. So it was kind of quite a good project for it. So go on, Rob, you can cover over the initial instructions.
I've got to read the slide before I can talk. So I'm not sure what order it's. Yeah, so this is a little bit what I was talking about a second ago. You know, when you are scoping this project, I think these are the sort of lessons we started to learn when we were doing these projects. You know, it's the first question. I think with any good project management or any good scoping of any project, the first question you ask is why, and the rest are what's. You know, why are you looking to get this model delivery? Mike just said we're looking to capture that bridge so that we can refurbish it. So that's where we want to concentrate on it. What we're going to do with it, make sure we wrote a specification document for the surveyors, which made clear to them, because I've seen people get burned quite a lot on this sort of thing. You know, what format should this information be pushed out in? You know, because point clouds, as anybody will tell you, or these laser scan formats, they come in any magnitude of different formats, and different softwares can read different things. So you've got to make sure that you understand what exactly you're getting into. What tolerance do you want that survey to be captured to? You know, if you're capturing if you want things to be captured very quickly, so for example, I've done some work with the Highway Agency recently. You know, they only want to know the locations of assets and the basic configuration of them. They really don't want to have a sort of really in-depth. They don't want to spend half a day on site with a UAV sort of flying around a bridge. They want to drive a vehicle underneath it and capture it that way. So, you know, what level of accuracy are you looking for as well?
So yeah, on this project, we worked out we wanted the photos, we wanted a photogrammetry model, a dimensionally correct model inside Recap or Point Cloud, Recap Autodesk format because we were going to use it inside Revit, a CAD mesh for a background reference, and also as a nice to have was an FBX visualization so we could do some visuals on the project. So I'll let you go on the airspace one. It's your...
So we started. Our first project that we tried this out in was a job in Kent. Was it Kent?
Yep.
Yeah, it was an historical site. And I thought, oh, this is ideal. It's dramatic topography. It's got a lot of stuff to really test this workflow out on. And we went merrily ahead with it, and we phoned our surveyors up and went through all that sort of process of scoping with them. And then the surveyor said, "You have checked whether it's not in a no-fly zone, haven't you?" To which I said no. And he said, "Oh, go to this website and type in the location." So there's a website called skydemonlight.com. It's free to use for anybody. And it's actually quite an interesting site, especially if you're a geek like I am. And you can actually look at any location in the UK, and there are an incredible amount of restrictions to airspace in the UK. You know, if you're near an airport, it's obvious that's going to be a big restriction. Military sites, cities, but even things like aerial masks and stuff like that, and turbines can cause no-fly zones to be in that particular area. And those no-fly zones can operate at different altitudes as well. So it's not just a case of this area is covered by a no-fly zone. It might only be the first 3,000 feet that's got a restriction on it, and the rest of it's okay. So you need to know and research that. So long story short, that job in Kent that we were going to do got scuppered because it was in a no-fly zone area.
Fortunately, our site on this one was just down here, so it was fairly clear of anything other than kind of a gliding club and a radio mast in the middle of the island there.
So you've got to become civil aviation experts now.
Yeah. So step one of the process was to go to site, as our little drone taking off again, and take loads of photos. So you'll see these are some of the actual outputs we had. They don't really look like they're changing much photo to photo, and that's because you want to get a good overlap between all of these photos so that the photogrammetry model will work. So I think of this tower, we ended up with about 650 odd photos to get just that tower and bridge in. Okay. And with photogrammetry, more is better. The more photos you take, the better model you're going to get at the end of it. Step two is you sit and wait, and you wait and you wait a bit longer, and you wait a bit longer, and you get the photogrammetry model to process. This is the bit where more photos isn't better, because it takes longer to process. So what do we do for the processing? We looked, again, as this was a research project, to find out what different softwares are on the market and kind of benefits and downsides to each one. So we won't cover all those detail, but the 6 we looked at was Autodesk's Recap 360, previously 123D Catch. We looked at Agisoft Photoscan. We looked at Bentley's offering Context Capture, which used to be called Acute 3D. We looked at Pix 4D, Capture and Reality, and Autodesk Memento, which is a beta version. The last 2 were beta versions. Those were 6 that we chose that seemed to be the most common used in the market. There's still a load of other ones we didn't investigate as well. So some of the processing times, like I say, there's a whole hour-and-a-half presentation of this, of what the benefits and downsides are to each one. But basically, we did Autodesk 360. The main things for it is that it's on online only thing, or was at the time. Online only, processed in the cloud. We thought this will be nice and quick. Out of all the other softwares that process on your computer, this one will be fastest. That took 3 days to process. So upload your photos, do all the configuration, publish it, and then kind of wait 3 days to get an email in your inbox saying, congratulations, it's now complete. The only benefit to that being that it's not tying up your machine for 3 days, so you can carry on with work as normal, as long as you're not in a rush. Then to Agisoft. Agisoft, one of the most professional offerings at the moment, used by a lot of surveyors, and that took 4 days processing time on an extremely high spec PC with had about 128 gig RAM, churning away for 4 days there.
There is one thing to mention here, isn't there, which is that the Autodesk offering has a limitation of 250 photographs, which we found out the hard way. And Agisoft has an unlimited, doesn't it? So Agisoft was processing all 600 photographs opposed to the Autodesk solution, which did 250.
Yeah, I think that's something to remember. For all of these, the Autodesk one could only do the 250, whereas every other bit of software on here was processing 650 photos. So again, to be fair to it, the other piece of software had to process kind of 3 times the amount of pictures. Then we looked at Bentley. That took 3 days processing time, but on a much lower spec computer than the Agisoft, although it did have some problems. Pix 4D was about 4 days as well. Then we looked at Capture and Reality, which was amazingly fast. Actually, it came out of 1 day's processing time. And then Autodesk Memento, which is another cloud-based, took 3 days as well. So that's the processing. Let's see if it's going to open up. It is. And here is the output. So this is the Agisoft output point cloud. So this was the full 650 photographs, all processed. Let's say took 4 days, and then this was the output we got at the end. And you can see there's an incredible amount of detail in it. For a point cloud, I mean, if someone had sent me this and said, we've just been to site and laser scanned it, and here's the point cloud, I don't think I'd argue with them. I think to kind of just run through it, it looks just as good, just as crisp, just as clear as any laser scan point cloud I've seen. You can see just moving.
I think the thing to worth mentioning as well, isn't it, is that you know, there's a lot of there's a lot of angles in that capture, because you think there's a cliff face and a building next to one another, and pretty difficult topography there. You know, there's plenty of angles, like underneath the bridge, for example, that you couldn't capture really with any other process.
Scrolls up and down. So I'll give you a very quick 2-minute view now of how you can use this inside Revit. So hopefully it's going to fire up. So what you'll see here is this is the point cloud straight into Revit. This is Revit 2017, and just load it in as you would do with any other thing. So instead of link Revit or link CAD, we're just doing point cloud, brought in origin to origin, and it's dropped straight in, and we can see we can spin it round and do what we need to. That's great. So we want to start modeling from it. We can go to an elevation, And let's copy that up. So I'm just putting a couple of levels on, one about halfway. And let's get one at the top. So the first thing, obviously, I can see a pure elevation of this cliff now, and I can see that exactly how tall the cliff lift is. I can see how wide it is. I can dimension off. So already it's far better than any site photographs or anything I would have got from that. So that's what level 7. I'm not going to go through renaming them. Ground view. Okay. So that's that. So if I go to the level 6, this is halfway through the tower, and you can see there the outline of the tower, which again gives us a really good view of exactly kind of how deep these recesses are, how wide each pier is, how wide the tower is, and I can view that at any point up and down the tower, so I can see how far the panels stick out and deviate. Again, as you would with a point cloud. The only difference being here, there's a little bit of cool kind of blur on the lines because it's photogrammetry, not quite as accurate and as many points as laser scanning. You lose a bit of that detail, but for us, we wanted a rough model. If it was plus or minus a little bit, it wasn't too much of a problem. So then we could quickly come in, model the walls. Exterior. And up to the top. Just check them in quick. Get the idea. So you can model straight over the top of it, go to your 3D view, and you've got, take this down to the bottom, so ground, level 7, and those are then in there. So if I select and hide off the point cloud, I've then got my tower. And obviously, an hour or two's modeling, you can have the full tower with all of the parts in it. One thing I'll mention as another part between Revit 2017 and 2015, I know Kevin showed the kind of graphs that show what Autodesk have been doing with the processing times and the power behind this. If you look how easy it is for me to navigate around this point cloud in 2017, it's nice and quick. If I go back to the model we originally put together in Revit 2015 and I try and, it's going to work now. You've obviously got a much better computer than me. But the fan's kicking in. It's starting to go. If you've not got a very good laptop, then there's a real noticeable difference that if I span round, it would kind of freeze for about 10 seconds every time I wanted to spin it round. Whereas Revit 2017, there was absolutely no glitch at all. Unfortunately, on this, you can't see the effects of that, but you can. If you're stood over here, you can hear Rob's fan going in overdrive at the moment, trying to cope with it. I'll close that down.
Just trying to keep you cool.
Yeah. It's not working. I don't know on the file size, I just know on the actual speed of operation. But the file size here, because we're linking the point cloud, we're not bringing it in, it's not going to make a massive Revit file. So the Revit file will just be 4 walls, so I don't know, a couple of megs. Another nice feature in 2017 to add to the what's new in 2017 is if you classify this point cloud using, what's it called? Not recap. Yeah, recap. If you specify what the points are, you can then turn these on and off like layers, unlike previous versions. So if we go in the visibility graphics as well as your model and annotation, we get a point clouds tab now. I say this is a new feature. You can choose either scan locations or scan regions. So I've created one here for the bridge, and I can now turn off those points. You can see I can actually turn off the bridge. So now if I want to model my new bridge between the two, I can draw that in. If I turn that back on, you see it comes back there. Or we get the choice to override the color of it as well. If I change that to red. So we can then cut out bits and pieces that we don't want or we do want for our design. So when the new bridge is modeled in, we can see it in context of the land.
How is it scaled? How is it
I'll come on to that one in just a second. So the next one. So accuracy with this. So this kind of comes on to that question about how you scale it up. With this, all the computer's doing is it's taking a huge amount of photographs, joining them all together, finding common points to build you this 3D model. From a photograph, as you know, you can't get scale from it. If I take a photograph of this table, the computer or wherever else can't tell how deep that is, how high it is. So what we need to do is have reference markers, whether that's something on site, maybe it's a standard brick size, maybe you know the width of a door, or maybe you put those kind of little black and white targets around the place. You need some kind of marker on site that you know the size of. So we could say on this lift, we know that the lift gate is 2 meters wide. So when we get that model back, we can scale it up and say that is 2 meters. And it will then process into the right size. Coordinate system, again, same thing. You can set it up to real world coordinates, but you have to know the real world coordinates of a point on site. So you have to have a marker point or something on site where you know the X, Y, and Z values for. And that leads us on to the accuracy of this. So we looked at, it's very difficult to tell because accuracy can depend on how many photos you take, how far away you are when you take them, how much overlap, and different parts of the model can have different accuracies. But on this one, we looked at this front flat face, and we did some analysis on that and pulled out this graph here, which shows that all of those points on that front face were within plus or minus 12 mil of the face. So, and 95% of those being plus or minus 7 mil. I think for us, that was really kind of close enough for what we needed to do. It could be, and this is the slight disclaimer on it, that without kind of probably laser scanning it to measure it, it could be that the wall is plus or minus 12 mil, in which case this is 100% accurate, or it might be more than that. The only way we're testing that at the moment is by doing kind of more of these to see what we get. But it's difficult because every time you do it, if we took another 200 photos, we'd get more accuracy on it. So our next one is, that's all great. We had a drone, fly around for a day. What if you don't have a drone? What if you don't have access to this? What if you're in a no-fly zone? Well, you can still use the technology. And this here is a wall that was in the front of the lift. This was 102 photographs taken on a standard iPhone camera, something most people carry around in their pocket now. And those photos were stitched together. I think, never catch that one in time. This picture here really illustrates the point I'm saying about accuracy. What you can tell with this meshed model is the size of the triangles here are really small triangles. So there's a lot of detail there. And you can see every single mortar joint in that wall. If you look kind of at this part where we took less photos, there's much bigger triangles, and as it goes off over here, which means those areas have less detail because we took less photos there. Okay. You can see it's kind of a little bit. And then if you look to those trees and bits in the background, everything starts going a bit wavy, which you can crop out if you don't need them.
Can you snap to those points when you bring it into your Revit?
Yes, you can snap to point clouds. So.
When you took the photos, did you just sort of wander around it? Or how did you decide?
It's a lot of trial and error of kind of saying, you kind of do a few of these projects and you work out the best way, but say if I was capturing this desk, you'd want to stand and get pictures all the way around it at set intervals, making sure you get a good overlap each time, and taking photos from both a low level and a high level so that you get a view of it from kind of every possible angle. And it's really just a trial and error of seeing if you haven't got enough, you'll get bits that go off slightly, and you can't really have too much apart from the processing time. Okay. So, yep. You can do, as long as the conditions on the day are the same. So if you do it on a sunny day, because things like shadows and stuff have a problem. But yeah, if you had similar weather conditions and similar light conditions on both days, you could go back and just add more photos and then reprocess it with double the amount of photos. Do you want to cover this one, Rob?
Yeah, sure. So yeah, obviously one of the, as Mike's slide at the very beginning said, you know, we were trying to measure this against other types of surveying like laser scanning, traditional surveying, and so forth. So it was important for us to understand the cost. Now we haven't as of yet, and I say as of yet because I know there might be a plan to, we hasn't as of yet done this via done laser scanning of this site to sort of compare and contrast. But a traditional survey was carried out on the site using a vehicle-mounted access platform, cherry picker sort of vehicle. The cost of that was $2,105 per day, which doesn't seem unreasonable really, plus the cost of the surveying and the staff costs that were there obviously as well. Obviously there was just mainly because of this site really. It's obviously on an island. You know, they had to be in this particular project a special provision put in place to get that vehicle to the site in the first place because it had to go over on the ferry. So they can, because obviously it's a very large unit, so it has its own access problems in many ways as well. Photogrammetry survey in comparison costs $1,250 per day, and I think if we had been gabbing to them as much as we had, it would have probably taken them less than half a day to complete it. You know, it's not a long process really. I know Mike, you've done projects over in Cumbria, haven't you, as well?
Yeah.
Similar
I mean,
time frame?
the total flying time was, they do 7 or 8 in the end.
Yeah.
7 or 8
I think it was
flights
8, yeah.
at 10 minutes each. So you're talking kind of just over an hour's worth of flights to capture those 650 photos.
This could be a temporary problem as well, but we did have interest. You almost need an extra person with you to guard the people that are flying the drones from distractions, because local people will come over and want to know everything that's going on. One chap that we had on site, what did he spend over with us? 25, 30 minutes?
At least.
Yeah. He was a nice chap, but he was distracting the pilots. So yeah, but the actual associated costs are not that high with these types of services. So I think they do offer a viable alternative.
Okay. So yeah, really lessons learned was to check no fly zones. That was our first problem. Make sure you've got markers on site. You know the distances between, so that you can scale this up when you get back to the office. If you've just got a load of photos and you process it and you don't know the size of anything on site, then your model is almost useless. Ensure your photos are taken of a good quality, you've got enough overlap. Know the software limits you're going to use, so which software, and things like the recap one with the 250 maximum photos was no good for us on this project. And also, you've got to prepare for the waiting times of how it's processing as well. So there's no good doing it today and expecting to be working on the point cloud tomorrow, because photogrammetry is just not going to be any good for you in that case. And I think I'll just end up and say the first project there, the Shanklin Isle of Wight, was a research project for us. Since doing that, we've said this really is viable. It is a useful bit of kit. This was a recent highway project we did. You can see it's a kind of couple of miles of highway there. If you concentrate on that kind of red bit in the top right-hand corner there, I'll crop it down on the next one, and that shows you this red bit, which was a new retaining wall we were installing on the road. So we had to get this project done really quick. The road had kind of washed out. We flew the drone over in middle of January. This photo in the bottom left here was beginning of April, and the photo on the bottom right there was about 3 weeks ago that it's now pretty much finished. So it really helped us having that information to be able to model it, show it in 3D, see how things integrated to actually get this turned around from project to on-site completed in a couple of months.
Yeah, I've heard in the media that this project finished ahead of time.
Yeah.
Obviously, it's quite a well-known one because of the disruption it caused the local, not the project itself, but the collapse of the road,
Yeah.
and the impact it's had on locals. Would you say the survey has assisted in delivering the project faster?
Yes, I would. I'd say the design process, it's sped up a little bit. It's really helped being able to see what the design is. But the biggest thing with this one, it was after the flooding around the new year, the road washed out, so the road was completely unsafe. We couldn't send any surveyors down there. We couldn't send people down because the river was still running through. So by actually saying, if we just fly a drone over the top of it, then we haven't got to send people there, and we can capture it. We don't have to wait for the river to go down. So we got the information we needed 2 or 3 weeks earlier than we would have been able to get had we had to send people there. And then using it for the checking we've got enough cover and everything, it has been a real help getting this one done before time.
How bad was some of that actually on the road?
Was it 30 meters a second of wind?
Yeah, minor gale.
Yeah.
So it's the weather conditions will play a part in how far the drone, how close or proximity the drone can fly to any asset. So in other words, because on the day we flew, it was incredibly clear and still. We got within how many meters? Was it 4?
Yeah,
5?
it's about 3 or 4 meters.
3 or 4 meters of it was flying within 3 or 4 meters. They did say if the gust had been if the gust had been higher than that, then they would have had to have come away from the building a bit more. Although there was never really, I don't know how much of an impact that would have actually made on the actual capture.
No.
It would have been interesting.
The thing with it is that's really down to the drone itself.
Yeah.
Obviously, the more expensive, better drone you use, the better stabilisation it's got in high winds.
Which is probably a good argument for using, as well as all the other arguments about having all the licenses and permissions and the experience. You know, the likes of, we used Resource Group, which is a company we used for the Shanklin site, which was they used the Topcon Falcons, which are very, very good pieces of kit.
Again, just another kind of quick illustration here. Top picture shows another bridge that was washed out as part of the flooding. Again, by flying a drone over, managed to actually model in a new highway a lot quicker than we'd be able to do traditionally. And you can get views.
How long did you do on the tower?
Yeah.
You did fly, each one was about 10 minutes long, and you did about 6.
Yeah.
How did you do that one when it being so large? Did you have to do really
It was done with, in actual fact, it was less. If I go back to that one, that was, I think off the top of my head, about 400 photos. So it's actually a lot less. It was flown up and down a path rather than going round a circle. However, the accuracy in this one isn't as good. So the tower, we said it was kind of plus or minus 5, 10, 15 millimeters. This one might be plus or minus 20, 30, 40 millimeters. But in terms of knowing how many cubic meters of soil we need to bring in, to be plus or minus a meter was really good enough for the purpose. So again, that comes into when you acquire a survey, what tolerance do you need? Not just going in and saying, I need it to be to the closest millimeter. If you're doing work like this, then you can really do it with less tolerance. I mean, this one, it was even less. This one was kind of about 20 centimeters tolerance because we just didn't need it. We wanted to fly over it really quick, get it captured in about 10, 20 minutes and go back to the office and start work on it. Again, another view there. It shows there's a kind of few holes and stuff in this because we just wanted it quick to get that background. And then the other end of the spectrum, been playing around with more tests of detail. So here's a kind of curb down the road for me. This was 65 pictures, just taken in more detail, processed, but it gives you a huge amount of kind of detail and accuracy in there. Going down to kind of a 1 cent coin and all the detail on that. So the more photos you take, the closer you take them, the more accuracy and detail you're going to capture. Even down to capturing a fly as well. It is possible if you take enough pictures and get them close enough.
Really got to get out more on this.
Yeah, I know. You know, actually, the photos folder on my computer is now starting to fill up. So a real quick whistle-stop tour of what we've been doing, but hopefully it's been useful.